Hi, it's James Governor, co-founder of RedMonk, and we're here for another conversation with RedMonk. Today, we've got Holly Cummins, Senior Principal Software Engineer at Red Hat. This is the second part of a discussion that we're having about sustainability, power usage, and software systems. So, hello, Holly.
Hello, thank you for having me.
Yeah, no, I'm excited actually. This is a great topic, one that we don't always think enough about. In framing this discussion, it's clear that organizations and individuals do have an opportunity to do more in order to reduce power consumption more broadly. This is something that you talk about, Holly, from Project Drawdown, where there are benefits you can get that are often a double win. So rather than it being sort of self-flagellation, this is something I don't have, it can be something good. So do you want to talk a little bit about that before we dive into some of the specifics of what you're building from an engineering perspective to support this?
Yeah, absolutely. I think opportunity is exactly the right word, because instead of thinking of it as a sort of an obligation, what we see is that a lot of times the action that you take to reduce your carbon footprint has all of these secondary benefits. So almost always it reduces cost. There's big business benefits as well, because we're seeing a lot of good commercial pressure on organizations to reduce their carbon footprint. And so businesses that can demonstrate they're sustainable have a competitive advantage. And so then you sort of reduce your costs and you've made yourself more attractive in the marketplace, all while saving the world. So it really is this sort of, it's like killing six birds with one stone.
Six birds with one stone. That's a terrifying image, but
it is, and it's not the most ecologically conscious image.
No, maybe not, but we'll work on that one. We'll work on that part of the story. Yeah. But I think that from that perspective, in compliance terms and really software engineering perspective, I'm talking a lot about making the right thing the easy thing. We talk about convenience as the killer application at RedMonk a fair bit. Packaging things up. If you package things in the right way, in terms of sort of jobs to be done, make things easier for people, they will do them. And so part of what we're trying to do today in software engineering, I think, is making it, think about shifting testing left. We think about a lot of the movements that we're currently about. It's making it easier to do the right thing. And so I think from my perspective, part of that is developer experience and practitioner and engineering experience. But let's dive into Quarkus then, and what is it, and why is that going to help us to build more sustainable or migrate to more sustainable production systems?
So Quarkus, it's a Java framework. We call it supersonic subatomic Java. And what that really means is it's really ridiculously small.
By the way, is there a supersonic subatomic song? It sounds like it should be sort of a hyper pop sort of song.
Or something that Daft Punk did a while ago.
Yeah.
Not to my knowledge, but it's ridiculously small and ridiculously light. And I use ridiculous because sort of compared to more traditional cloud native frameworks, for a basic REST app, it both running on the JVM, so just a vanilla JVM, Quarkus will use maybe half the memory and it will start in a quarter of the time.
Okay.
And so Quarkus has two modes. It can run on the JVM or it can run on GraalVM as a sort of a natively compiled binary. And when you go to native, it is truly ridiculous in terms of how fast and light it is. So it uses 10% of the memory and it starts up 250 times faster. So I benchmarked that against light switches because it really, you sort of perceive it as instantaneous. And it's actually about twice as fast as an LED light bulb starts, like a best of breed LED light bulb. So it is, we talk about light switch ops and it is completely that sort of light switch.
Okay. So we're no longer able to have that cup of tea between starting the system and using it.
No, that's the downside, is we've lost.
See, that's another kettle's worth of energy saved, Holly. There you go. All those cups of tea.
No regret solutions.
No regret solutions. That's what I'm talking about. So you've been doing some maths. You've got some charts. I'd love to see them. I'd love to see some of the way you've been looking at this. I think that developers love numbers. So let's have a look at if you can frame it a bit and just show some of the stuff you've been working on in thinking about how Quarkus could be relevant from a low power systems perspective.
Yeah, so when we sort of started thinking about this, those metrics I said about, starting up 250 times faster and stuff, you can see those on the Quarkus homepage, and we had those numbers for a long time, and we kind of felt intuitively like if it's this much faster and lighter, it should use less carbon, right? But we hadn't actually measured it. So what I've been sort of working on is trying to validate that intuition and actually get the numbers to confirm that it is faster and lighter. And just as a spoiler, it does use less carbon. But let me show you what we've got. So as a sort of a starting point, when we think about reducing carbon, there's sort of a question of like, okay, well, but how does it reduce carbon? Do we have to do anything special to reduce the carbon? And with Quarkus, just for free, out of the box, if you don't do anything else, but you switch to using carbon, sorry, I've started talking about Quarbon.
Oh yeah, I can see how that would happen. That's going to be a problem.
Yeah, but if you just switch to using Quarkus, you will see that your energy usage is lower because you've got a lower RSS, so lower memory usage, and memory costs power. And the other thing that's not necessarily obvious just from saying it's lighter and faster is the throughput is also higher. So for the same resources, you have more throughput. Okay. So that's quite good. It's quite easy to measure. There's sort of this direct benefit. But then going back to some of the things that we were talking about earlier, when you use Quarkus, you can start to run your organization differently. You can start to manage your data centers differently. You can start to manage your cloud differently. You can maybe invest in some other automation. And with that, you get a whole host of further benefits. So for example, because Quarkus gives you a higher throughput for the same resources, if you're running in the cloud, you maybe can change what machines you're provisioning, and you can provision a smaller, cheaper machine. So then that saves you cost, and it saves you the carbon. So again, is this sort of double benefit. And even if you're running in Stockholm or something like that has the really clean energy, it's going to save you the embodied carbon of the hardware. So it definitely is a win no matter what. Okay.
I think that's one of the big things is that, it's all very well and good, say, just move to the cloud, but there is an embodied carbon. It's a bit like with the auto industry. We've got EVs now, and yet we're building these massive, horrific electric vehicle SUVs, when what we should be thinking about is micro-mobility, sort of, redesigning based around small electric vehicles, more bikes, more scooters. So maybe Quarkus is part of the micro-mobility movement, as opposed to massive SUVs, massive embodied carbon, as you say. And I'm sure sometimes, there's, if a 50-year-old car it may have an engine that is not efficient, but on the other hand, using that car, you're not having to. The best car is one less car, in my view. But there again, I'm not a petrol head. So embodied carbon. So let's not talk too much about cars. I may have sort of lost the plot there a bit.
But actually, cars is an interesting one, because again, I'm going to spoiler it a bit. But when you buy a car, if you are a petrol head, you have this really sad choice of like, do I buy the one with the 4-liter engine that's going to go vroom, or do I buy the one that goes put, 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 that, makes me feel more virtuous? But with Quarkus in particular, what we're seeing is it's not like that trade-off where you have to sort of have the joy or the virtue. With Quarkus, it goes faster and it uses less energy. So you make the switch to Quarkus, you've got the higher throughput, and it was better in terms of its carbon footprint, which is sort of counterintuitive. And I think there's a mental adjustment to like break the analogy with the car and go to actually faster is cheaper.
Okay. Well, let's have a look.
Yeah. And so, before we do, just the one other thing to talk about in terms of the sort of the organizational changes is elasticity is really important, because we want to be able to stop workloads when we're not using them, and we want to be able to, if the demand drops, scale down. And with Quarkus, because we talk about light switch ops, which is, sort of like how we go around the house and we turn off the light switches and we don't feel any sort of fear or regret when we turn off a light switch in a room that we're not using. We need to get like that with our organizations too, and turn off workloads that we're not using and then turn them on in the morning when we come into work. And because Quarkus comes up as fast as a light bulb, literally, then it's a really nice fit for that kind of light switch ops.
Okay. Yeah, I mean, you need to be able to turn it back on again quickly if you're constantly turning it off. So makes sense.
Turning it off is one thing, but it's the turning it back on, which is where a lot of workloads traditionally have stumbled. So to sort of answer that question of, well, intuitively we think Quarkus should be more carbon efficient. Is it actually? One of my colleagues did an experiment about a year ago where he was looking at cost. Mm-hmm. And so he found that comparing to sort of a legacy framework, he had a sort of a workload, and it was just sending 8,000 requests a second, and he left it up for 20 days. So it was quite a sort of a stress test in terms of, not like a little micro benchmark where, you run it for a minute, but he ran it for 20 days. And he found that for the legacy framework, he had to run it on a T2.medium instance. Mm-hmm. With Quarkus on JVM, he was able to go down to a T2 micro instance. So instead of being about, over $30 an hour, it was under $10 an hour. When he went to native, kind of interestingly, even though native starts up so much faster, it did need the same size instance, because its runtime characteristics were broadly similar.
Okay, I've got to tell you though, I'm quite triggered by this, because it's US East 1.
I know.
and I mean, if you're going to be running something for a couple of weeks, I mean, even for testing purposes, please don't run it in US East 1. That's the worst default from an energy perspective. So that's my call to action. Please use a different region.
Yeah, I should say, actually, he didn't run it in US East 1.
That was just the cost. Okay.
Yeah, so this is just the cost for US East. Yeah.
Okay.
Yeah. Yeah, I did have that thought as I was doing this diagram.
No animals were harmed in the making of this benchmark. Okay, good.
Yeah, exactly. US East 1 is unfortunately a popular location, which is why I chose US East 1. But don't run your workloads in US East 1.
Got it. Don't do that.
Yeah. So then the question is, okay, well, that's just cost. So how does that translate to carbon? But the good news is we're getting, because there's more and more interest in this space, we are getting the data sets now. So there's a data set called the TEEDS data set that sort of allows us to convert from the instance, if we know the location, to the carbon. So taking that same experiment, looking at the carbon, you can see that it's not exactly linear, but it's about half the carbon for Quarkus on JVM compared to the legacy framework. So we're seeing, this quite substantial carbon saving. And that's, again, I did it in US East, but, even if you're running in Stockholm, you're going to see, because of the embodied carbon, you're going to see that difference.
Okay. And these are pretty substantial savings from a carbon perspective.
Yeah, and the thing about it is, going back to the no regrets, is you've got this big saving, and Quarkus is really, really nice to use. So a lot of developers choose it not for those cost reasons, but just because the programming model is so delightful. Developer joy is one of the things that we talk about. So you sort of get this double win of, my developers are really happy and they're more productive. Oh, and I've just halved my carbon footprint.
Yep. So developer experience, making the right thing, the easy thing. No surprise that someone building Quarkus thinks that it is a delightful developer experience, but We are hearing some pretty good rumblings from the market at large. So yeah, that's fair.
Yeah, and we're sort of, we're hearing that from our customers as well. Often, they sort of, you come for the developer experience and then you stay for the reduced costs, or the other way around, where their starting driver is, we want to reduce our costs, and then they go, oh, wait a minute, our developers are much happier.
Okay.
So this is sort of looking at it in a cloud context, and it's only kind of indirectly measuring the carbon based on these sort of statistical data sets.
Yeah.
But last week we did another set of experiments where we actually directly measured the power consumption, which allowed us to then work out the carbon.
Well, so hopefully Amazon is beginning to get a bit better with its carbon calculator, and we might. I mean, it's still. I think it's early days for the product. It's really not designed to enable you to make thoroughgoing choices about different regions and so on. But hopefully, yeah, that'll improve the data that you're able to glean around actual carbon, as opposed to cost as a proxy.
Yeah, definitely. It's an area where we're seeing a lot of activity, and it's still a little bit of a Wild West. So there's sort of one of the things that we as Red Hat would really like to see is more open methodology. And because each cloud vendor tends to use a slightly different methodology, which means it's sort of quite hard to compare. So some, don't include scope 3, some do include scope 3, and then you sort of end up going down into the weeds, and you have to become a carbon calculation expert, which nobody wants to be except for a few people. So hopefully we'll see more sort of openness and standardization there.
Yeah, it's needed.
Yeah. But when you're outside the cloud, you do have more direct access to the hardware. So then you can directly measure the carbon, which is what one of my colleagues in the performance lab did. So he looked at a couple of different frameworks. So he looked at Quarkus on JVM and native, and then he also looked at the same, it was a different benchmark, but it was the same legacy framework, and he looked at it on the JVM and also on native. And what this is showing you,
so legacy framework, do you just have to be really polite, or like, I feel like this is a bit, I mean, I feel like we know what the legacy framework is, or, I mean, this is a bit.
I will leave it to the viewer as an exercise to work out what the legacy framework is, but I couldn't possibly comment.
Yeah, we needed to work out, because I know what it is, obviously, the legacy framework. But anyway, yeah, we'll move swiftly on. But that's just one. I don't want to drop you in it, but we didn't. I forgot to. Anyway, go ahead.
Yeah, I mean, I think for all of us, really, it's about us doing the best that we can in the domain over which we have influence. And so for us, that's how can we make Quarkus as carbon efficient as possible. And comparisons are useful, but ultimately it's about what are we doing, how are we optimizing to bring our carbon footprint down. And hopefully everybody else is also doing the same thing, because then that's best for the industry. So in this chart, it sort of, this was kind of a capacity test. So he shoveled as much load as possible into the application. Mm-hmm. And basically what would happen is eventually he would shovel enough load in that it would just fall over.
Okay.
And so the line stops when it falls over. So you can see Quarkus on JVM managed to digest the greatest amount of load. And it also, for any particular load, used the lowest amount of power, which meant it used the lowest amount of carbon. Oops, that was not what I intended to do. Quarkus on native, interestingly, it couldn't eat quite as much load, and it did use a little bit more power, which is maybe a slightly counterintuitive result. So it means that with native, sometimes it's going to fix your problem. Yeah. Sometimes actually, because the throughput isn't as high, and throughput actually is proportional to efficiency, which means it's inversely proportional to energy usage, you may be better off with JVM rather than native. And it's going to depend on how you're using it. So for example, if you're using it in a serverless context, then maybe the elasticity gain, going back to that first chart, the elasticity gain that you get from going up and down means that overall with the system's thinking, you're better off with native, even if on this particular chart, native is slightly less good.
Okay.
And then what you can see as well is for you know, in both cases, native and JVM, Quarkus does have that greater efficiency, and it can handle greater load than the legacy framework. And we see an even more noticeable difference when we go up to higher load. So this was just one instance. How much can I send at it? But what if I want to go up to 40,000 requests a second, 80,000 requests a second? At that point, what we see is you'd need fewer Quarkus instances, to handle that load. And so then you see an even bigger efficiency difference, and so an even bigger carbon difference.
Okay.
So you can see on this one, like the line is fairly, you know, it's a much gentler slope for Quarkus. So you can go up to a huge number of requests per second with a fairly small number of instances, which means you're saving a lot of carbon.
Okay.
So that's the graphs for the day.
Okay, there you go. I mean, I think that it's really good to see this. You know, think about well, obviously, yeah, engineering, you have to bring some science to it. You do need to bring some maths. You do need to understand what you're doing, sort of not rely on assumptions. So that's super helpful. Oh, yeah. So customers is one thing to have this like, oh, here are some charts. And in one area, I'd like to see more baselines. You talked about standardization from an industry perspective. But one thing I would exhort Red Hat to is to support Holly. And when you get those customer case studies, find some standard ways of expressing the benefits that they're getting from a carbon perspective. And you have got some pretty impressive customer wins that we're allowed to talk about. We should talk about. So yeah, what have we seen from a customer perspective?
So we're seeing some customers are coming to us specifically because of those sustainability concerns. So for example, Decathlon have done a greenfield development with us. And unfortunately, because it's greenfield, we don't have the before and after.
Do Americans know what Decathlon is? I feel like, I don't know, do they have it in? Decathlon is a retailer of sporting goods. And I think Europe's biggest. They're everywhere, massive shops, good prices for sporting goods, bikes, all sorts of things. And I guess it makes sense that somebody involved with supporting people in their outdoor activities would care about sustainability. So that's Decathlon. Sorry, go on. What?
Yeah. So they've done a greenfield, so we don't have the before and after, but they sort of came to us because they said we're looking for something that's ecologically friendly. And like I mentioned before, they sort of, that was one of their considerations in selecting Quarkus, but then they also got a lot of benefit from that developer experience.
Okay.
For some other customers, we do have the before and after. So Lufthansa have started migrating some of their workloads to Quarkus, and for them, one of their main drivers was the cost considerations. And so then they were seeing that they could get about 3 times the density of deployments as they could before. So again, there's that huge cost saving. And that's really nice, because I always feel a little bit uneasy when we do something in the performance lab of like, oh yeah, but this is a benchmark. Does it actually translate? And so it's really nice when we're starting to see these customer stories rolling in that are confirming, yeah, we did it.
And so to what extent, I mean, given everything we've seen in the charts and everything else, I mean, the Lufthansa example where they're seeing that greater density, will that directly be correlating to a carbon benefit?
Yeah, unless again, it depends how you run it. So you could run it in a virtual machine per Quarkus instance and then not take advantage of that density, and then you wouldn't see that. But for how they were running it, they were able to run smaller instances. I think again they had these sort of huge 1 gigabyte heaps that were costing them a lot, and so then they were able to reduce those. So yeah, it does directly translate to the carbon.
I mean, obviously, aviation is one of the industries that is a problem. But we like to fly, so I think Lufthansa needs to do the work and let us know what they need to be thinking from. I'd love to hear some reporting from them on sustainability as well, because that's a couple of great examples. Any other?
Yeah, we had sort of a similar story with Vodafone Greece, where the sort of the starting consideration was the cost, but then that carbon reduction was this sort of great secondary benefit along with the other. I keep saying no regrets, but it fits so nicely that they had this sort of the developer experience. And what they saw was they were able to reduce the resource usage by 50 to 60% compared to the framework that they'd migrated from. So again, we're seeing this sort of heuristic of like 2 to 3 times lower resource usage from a bunch of customers, which is really nice.
The problem is every time I hear no regrets, I can just see the tattoo in the movie, no regrets. But there again, another exercise we'll leave to the reader to whether they've seen that movie. So perhaps comment, let us know. No regrets. So okay,
win-win. It can be win-win.
Win-win. No regrets. Carbon. Yeah. Okay.
No birds were harmed in the making of this benchmark.
There you go. So we talked about the context. We talked about the maths. We talked a bit about the customer. I think we've talked a lot, and it's probably about a wrap for today. And I'd just like to say to everyone watching, this stuff is important. You can make a difference. Stuff can be a little bit scary. Certainly some of the heat waves we're all seeing globally. I think it's time to stop saying it isn't a problem. But yeah, you can make a difference, and you can make a difference through software. And it was a real pleasure having Holly Cummins here today, telling us a bit about how you can do that. So thank you, Holly.
Thank you.
And that is another Red Button Conversation. Got any feedback? Let us know in the chat, subscribe, comment, tell us more about what you're doing from a sustainability perspective, and put pressure on your vendors. Once again, thanks everyone.